Students, in today's class, we will see the power consumed in AC circuits and we will study about some important AC circuits. You will find this in the chapter of alternating current. Okay? Okay, let's start that how much power is being consumed in the AC circuits. Alright. Before moving to the AC circuits, it is important to know that in any DC circuit, the potential difference or the PD or the voltage, whatever you want to see, and the current are always in phase. Okay, so who are the who are all in phase? First of all, the PD, that is your voltage, along with it the current, they are in the phase. In the case of DC circuits, all right. Okay, students, I'm writing the term alternating in short, but in your exam you will write the full term alternating current. All right. But students, this particular thing, that is the potential difference as well as the current, that I told you all that the two things are in phase in case of the DC circuits. This is not so far for the AC circuits. Alright. So in general, a phase difference is evolved between the voltage and the current in the case of this AC circuits. So mathematically, as we have seen that the voltage and the current can be expressed by some equations. So let's write those equations. For the voltage, we can write it as V equals to V naught sine omega t. And the same way for the current, we can write as I equals to I naught sine omega t minus theta. Alright, so what is this theta, students? You can ask that theta is the phase difference between the voltage and the current that we have seen. Alright, so and theta, students, this theta will always lie between minus 90 degree and plus 90 degree. That means minus 90 degree to plus 90 degree, that theta will lie. Okay, and it can be sometimes it can be equal to also. That means sometimes this theta value can be to negative from 90 degree, that means minus 90 degree, and sometimes it can also be equal to plus 90 degree. So let's put the equal to sign also. Alright, so for this particular condition, the power consumed or the power dissipated, both ways, either consumed or either power dissipated in the circuit, will be how much for this for this condition. Okay, that means when your theta is lying between this and this current is having the phase difference between the voltage and the current. So for this particular conditions, the value of your power will be P equals to VI. As usually we write the expression P equals to VI for the power. So let's put the value for V and I. It's V naught. I'm just copying from here. This is for expression of V. And what's the expression for the I? Alright. Okay. So if you just arrange it mathematically, it will come to us like this. V naught, I naught and sine omega t. Okay, V naught, I naught, I'm just taking it out as because this is your constant. and sine omega t, it should be a common term between these two. Okay, within these two things that are given in the bracket, so I'm taking it out. So within your bracket you will be left with sine omega t cos theta minus cos omega t sine theta. This is purely your mathematical concept. Okay, so after this what we can do, now let's put the sine omega t here. Okay, this we did just to arrange it mathematically. Now let's shift this sine omega t into the, push this sine omega t within this bracket. So we have to multiply it. Okay, so yes, so third second step is also done. Now for this particular term we can write in some other mathematical way. So let's see in which way we can rewrite. This will remain same. For this part, see how I'm writing, half into sine 2 pi omega t sine theta. This is one formula, students. You can go through your maths book for the formula. Okay, that is your 2 sine omega t cos omega t equals to sine 2 pi 2 omega t. That is the formula that I've used here. Alright. So students, nearly we have seen that what the expression for the power can be expressed. Alright. And over a complete cycle, that means when the cycle will be completed, the average of sine square omega t we have seen, its value will be half, just 1 by 2, and that of the sine 2 omega t's value will be 0. Okay, I'm writing it here. Sine square omega t, our expression, this is done. This is the another part, it is half, and sine 2 omega t's value is 0. Okay, this is when this value will, when we will get, when the cycle is completed. Okay, so and the average, this is the average thing, that means the average of sine square omega t's value is half, and the average value of sine 2 omega t's value is